welcome to the notes on distributive property equations. Again, we are now working on 8th grade material. This is topic 12-3 in the accelerated version of digits. I'm going to have you guys take a look at the launch on your own. What they'd like you to do is go ahead and decide what tiles are equivalent to each other. So go ahead and give that one a shot. Okay, so what I've done is I've just gone through and rewritten an equivalent expression to each of the tiles. A couple of them we didn't really need to do anything. I just find it easier to compare the expressions when they're all in my own handwriting. So that's why I rewrote all of them. This concept was definitely one of the more confusing concepts in topic 7. So please make sure that you do have the same thing. That a negative 3 times s is going to give you negative 3s, and a negative times a negative will give you positive 15. So the ones that are deciding that are equivalent are these 3 and these 3. I find using highlighters, again, extremely useful. So now we're just going to go on and we're using exactly what we've talked about yesterday with having variables on both sides to now also having the distributive property being thrown in there as well. So I'm going to do question number 1 with you, and then I'll have you try number 2 on your own. So it says use the distributive property to solve, and then also we'll be following many other steps. So again, the goal of any equation is to get a variable on one side and a number on the other. And we want to keep solving the equation into a series of smaller equations to get our answer. So first I must apply the distributive property. So 4 times 8 is 32, and 4 times negative c is negative 4c. Then I will set that equal to everything else on the other side, 8c plus 16 plus 6c. And again, this is where I noticed a lot of people were struggling on to the homework today. You're going to take a piece of paper and cover up everything on the right side of the equation. So give me 1 second. All right, so this is where we left off. So I want you to cover up the right side of the equation, and then look at what we have on the left side, which is 32 minus 4c. I cannot combine those two terms together because they are not like terms. So right now, that left side is as simplified as far as it can go. Then I'm going to cover up the left side. Look at the left side, because that is an expression, and decide, are there any like terms that you can combine together? And I see that I have an 8c and a negative 6c. And since these are on the same side, you perform the same operation that you see. So it says 8c minus 6c, which will give me a positive 2c. I'm not doing anything with that plus 16, so I bring it down. I'm going to remove my large block here. Now, again, the goal of the equation is to keep solving a series of simpler equations. So I'm rewriting the 32 minus the 4c, and I'm writing it directly across from the 2c plus 16. Okay? Now, again, this is a spot where you have 4 opportunities to solve this problem, and you can do all 4, and as long as you go through and solve it correctly, you'll get it right. But again, what would Mrs. Dean do? I'm going to look at my coefficients and variables, and I have a negative 4c and a positive 2c. I'm going to look to see which one has the smaller coefficient, and the 4c, the negative 4c, is technically smaller. So to cancel out negative 4c, I will add 4c to both sides. And I can only add the c to the other term that has the c with it as well. So that leaves 32 equals 2c plus 4c to give me 6c. And I also haven't done anything with that positive 16. Now it's just a normal 2-step equation. I'm going to have a minus 16, and then I will have 16 equals 6c. I divide both sides by 6. And you will get a decimal, and that's okay. And you happen to get 2 6/10 repeating, which would also be the same thing as 2 2/3 if you wanted to write your answer. All right? So again, I think the best way to practice these is to just dive in and try them on your own. So go ahead and work on question number 2. Okay, I think this is the first time that this has happened so far with one of these advanced equations, but your answer actually ends up being 0. We can't avoid that. So I started again by distributing this 2 to the e and the negative 4, which left me with 2e minus 8. I then decide which coefficient is the smaller one, which is the positive 2. So I subtracted 2 from both sides, which left me with e, or you can put 1e if you want, minus 8 to give me negative 8. Don't forget to bring this negative sign down right here. Then I add 8 to both sides, and lo and behold, negative 8 and 8 right here are additive inverses, and they give me 0. So the steps are really to use the distributive property to solve. Then you want to combine like terms. So combine like terms. And then you continue solving for the variable. That's really the steps. So as you see, each day we're just adding a new step, and it brings us back to a previous step that we've already done. So now, on the key concept, it says that you can solve an equation with a fraction in multiple ways. We've already talked about that if you have an equation with a fraction in it, that's being multiplied by the variable, you can multiply that variable and coefficient by the reciprocal to cancel it out. But here they're telling us that one way is to begin eliminating the fraction from the equation. To do this, multiply each side of the equation by the denominator of the fraction. To solve equations containing more than one fraction, you can eliminate all fractions by multiplying each side by the LCM of the denominators. So this is the only time when you're actually allowed to do multiplication at the beginning, because you're multiplying both sides by the same amount. You are not changing the value or the equality of the two sides of the equation. So they're showing us this original equation of 12 equals 3/4 n plus 5. They are saying that since it has a denominator of 4, let's go ahead and multiply each side by 4. And notice they put parentheses around the entire expressions because we need to take and distribute that 4 to each term. So on this line, we have 4 times 3/4 n and 4 times 5. They then simplify that to get you 45. 4 times 3/4 will give you 3n. When you multiply by the denominator, you should just end up with a whole number. And then plus 20. Then they're showing their work a little bit differently than I would. They're showing the minus 20 right here. I would show the minus 20 right here. No big deal. They're leaving themselves with 28 equals 3n, dividing, and then getting their answer. Okay? So question number 3 is stating that two students, A and B, use different methods to solve the equation negative 20 equals x divided by 2 plus 7. One of the students makes a mistake. Find and correct the error. So we really need to look through their work, which sometimes is more challenging to look through somebody else's work than to just start solving the problem on your own. So I'm just going to rewrite the problem and put negative 20 equals x divided by 2. And this technically has a fraction in it. So I can say, okay, I'm going to go ahead and multiply both sides by 2. And it's okay to put your 2 on the right side here if you don't have room next to your equal sign. So look to see, did anybody start doing that? Well, student A didn't necessarily do that. Student B did. Does that mean that student A's work is incorrect? No. They had a positive 7 right here, and they said, yeah, well, can't I just decide that I want to get rid of that 7 first instead and subtract 7 from both sides? And so this gives you 0, and then negative 20 minus 7 will give us negative 27. Nothing wrong with what they've done there. So what we need to do is double check if student B, they did multiply both sides by 2. Let's check to see if their work is correct. 2 times negative 20 is negative 40. X divided by 2, well, if you do x divided by 2 times 2, that cancels out the denominator and just leaves you with x. And then, did they do 2 times 7 as well? No. That right there definitely is an error. And since they said that only one of the students makes a mistake, and since we found an error in student B, that was the mistake. Student B did not distribute through the parentheses. That should be 14, not 7. It did not distribute properly. Question number 4. states that an apprentice pastry chef has been left alone to make 8 cakes. He cannot remember how much sugar to put in the filling. Oh no! He knows the following, that each cake, not counting the filling, requires 1 1/4 cups of sugar. The head chef told him he would need a total of 12 cups of sugar for all 8 cakes and fillings. So write an equation to represent the situation and then find the amount of sugar needed for the filling in 1 cake. Ooh, well, if all of the cakes need the same amount of sugar, then I'm going to be multiplying 8 times the information in the question. So I got to really kind of pay attention here. What is it that they're looking for me to find? They're looking for me to find the amount of sugar needed for the filling. So I'm going to say that F is this going to be the amount of filling. And they said that each cake requires 1 1/4 cups of sugar. And I also know that I need some sugar for the filling for that same cake. So don't I need 1 1/4 cups of sugar plus the filling for the cake? But since I'm making a total of 8 cakes, wouldn't I multiply both of those by 8? So you could have said, 8 times 1 1/4 plus 8 times F, because that is the same thing. But when I set up my original equation, I can set it up showing the parentheses. And then since I need a total of 12 cups, it equals 12. So I'm going to distribute this out and have 8. And I'm at 1 1/4. I'm actually going to change that to 5/4 right here. And then plus 8F equals 12. I can cross cancel with the 8 and the 4, so this becomes 2 and this becomes 1. And so 2 times 5 will leave me with 10. Oops, this is 10 plus 8F equals 12. Subtract 10, which leaves me with 8F equals 2. And then be careful, don't do 8 divided by 2 because you don't want to get a fraction. You are dividing by the 8, which will tell you that F equals 2/8 or 1/4. So that means that you're going to need a 1/4 cup of sugar for each thing of filling. So even though we didn't know how much sugar they needed for the filling, because we knew the total amount and we knew how much the cakes needed, we could figure that out. I'm going to do number 5 with you too. I'm going to set up the equation with you. It says that the length of a rectangle is 7 feet longer than its width. I'm stopping right here and I'm drawing a picture of a rectangle because I'm very visual and you are as well. The length of a rectangle is 7 feet longer than its width. The perimeter of the rectangle is 26 feet. Write an equation to represent the perimeter in terms of W. So they want me to use W for the width. The length then is 7 feet longer than that. So W plus 7 would be 7 feet longer. So again, if this side is W, then this side also needs to be W. That's the definition of a rectangle. And if this is W plus 7 over there, then it has to be W plus 7 as well. So we could just go ahead and add all these together and say because the perimeter is 26, and to find the perimeter, I add all those sides. I'm going to go W plus W plus 7 plus W plus W plus 7. Or if we wanted to say we're using the distributive property, couldn't I be using that perimeter formula that says I'm really going to be multiplying 2 times W, and I'm going to be multiplying 2 times W plus 7, but because that W plus 7 represents the length of a side, I need to make sure that I put the W plus 7 in parentheses. Either way, you should get the same answer. So I will have W plus 14 to give me 4W plus 14. Then I will subtract 14. Hate when I run out of room, so I'm sorry about that. I get 4W equals 12. And then I would divide by 12, and I get W equals 3. So they're asking you what is the width of the rectangle, they asked for what was the length of the rectangle. So the width is 3. So if the width is 3, the length has to be 3 plus 7. So the length has to be 10. So the length is 10. You need to be clear that that is your answer that you've labeled. All right, we are going to pick this up on Tuesday, and then we also will continue reviewing a little bit more with the variables on both sides and distributive properties to make sure you're really okay with that before we move on to the next topic. Thanks for watching and have a great weekend.